An object from the void between stars is currently rampaging through our cosmic neighborhood. They're calling it 3I Atlas, and it's doing something no one saw coming. It's getting brighter, fast, doubling in intensity every few weeks while growing a strange green cloud 500,000 kilometers wide. Astronomers expected a faint flicker. Instead, they got a six-fold surge in brightness that has scrambled all predictions. What is fueling this thing? Is its core hyperactive? Is our sun unlocking alien ices? Let's explore this together. The numbers don't lie. So, what does the raw data tell us about this interstellar visitor? Right now, 3I Atlas is about 2 astronomical units from the Sun, a distance of roughly 300 million kilometers. The team at the Atlas survey in Hawaii, led by astronomer Larry Deneau, first logged it in early July 2025. But it's closing that gap at a staggering rate. Its current velocity is nearly 60 kilometers per second, and it's still accelerating towards its late October perihelion, where it will peak near 68 kilometers per second. That's faster than NASA's Parker Solar Probe at this distance and more than twice as fast as any planet. On the brightness scale, it has hit magnitude 12. While that's 250 times fainter than the faintest star visible to the naked eye, it's a colossal leap from its predicted magnitude of 18, which is a brightness difference of over 25 times. The comet is following a hyperbolic trajectory with an eccentricity greater than 1, the mathematical proof that its path originated far beyond our sun's gravity. These are the hard metrics: distance, speed, brightness, and they're all telling us that 3I Atlas is not just another rock passing through, it's a dynamic, evolving anomaly that is rewriting the book on interstellar visitors. The unexpected brightness surge. Why is everyone scrambling to get a look at this thing? Because in September, 3I Atlas went completely off script. The light curve, the chart astronomers used to track brightness, took a sudden sharp turn away from every prediction, a six-fold increase above what the models anticipated. This outburst sparked intense debate among experts like comet specialist Matthew Knight, with some speculating that the nucleus might be fragmenting. The cause seems to be its coma, the massive cloud of gas and dust boiling off its surface. That green cloud has expanded explosively, with recent measurements suggesting it now spans over 500,000 kilometers, meaning if you placed it where the moon is, it would stretch halfway to the Earth. As this coma grows, it scatters more sunlight, making the entire object appear brighter through our telescopes, even while the solid nucleus stays hidden deep inside. The Atlas team is logging every update and feeding the data to the Minor Planet Center, the official clearinghouse for these observations. This isn't just a comet getting a little brighter, it's a display of activity that is rewriting our expectations for interstellar objects and hinting at a very volatile composition. Racing against the sun's glare. Here's the problem. Just as this interstellar guest is putting on its most spectacular show, the curtains are closing. The window for watching 3I Atlas from Earth is shutting, and fast. Every evening, the comet sinks lower into the twilight, where atmospheric turbulence severely degrades image quality. By October 21st, the angle between the comet and the sun, what astronomers call solar elongation, will shrink below a critical 30 degrees. That's the point where even the most powerful ground-based telescopes, like the Keck Observatory, can no longer distinguish its faint glow from the overwhelming brightness of scattered sunlight in our own atmosphere. Professional observatories are already pulling back because pointing sensitive optics that close to the sun risks frying their multi-million-dollar sensors. Amateur astronomy networks are in a mad dash, coordinating global campaigns to get a few more images before it vanishes into this observational dead zone. Once it passes behind the sun, there will be a total data blackout lasting for weeks, leaving us blind right as it reaches its most active and violent phase near the sun. Mars, the last outpost. With Earth-based views about to go dark, the mission to understand 3I Atlas isn't over, it's just changing venues. The focus now shifts to Mars. For a brief period, a fleet of robotic orbiters will have the only front-row seat. The European Space Agency's Mars Express has its high-resolution stereo camera. The ExoMars Trace Gas Orbiter can sniff out faint gases. NASA's MAVEN, under Principal Investigator Shannon Curry, can use its imaging ultraviolet spectrograph to map outgassing and its plasma instruments to watch the solar wind slam into the comet's atmosphere. And the Mars Reconnaissance Orbiter, with its famously sharp high-rise camera, might even be able to resolve the nucleus itself. The key date is October 3rd, when 3I Atlas flies within 28 million kilometers of Mars. It is an incredible stroke of luck to have so much advanced hardware in the right place at the right time. For weeks, instrument teams have been running simulations and booking precious observation time in a complex multi-agency effort. This is our last, best chance to get close-up data before the comet swings around the sun and heads back into the interstellar void forever. The green mystery. What's the first thing you'd notice about 3I Atlas? Its color. The comet has a striking, almost unnatural green glow, and scientists know exactly why. Spectral analysis points to diatomic carbon C2, emitting light in what are known as the swan bands, centered around a wavelength of 514.5 nanometers. Here's how it works. Sunlight energizes carbon-based molecules in the coma, and as they relax, they radiate that specific green light. While this is known in comets, the intensity from 3I Atlas is off the charts, far more dominant than in solar system comets like Hale-Bopp at a similar distance. The vibrant green is a direct proxy for the comet's outgassing rate, telling astronomers just how much material is boiling off its surface every second. This intense C2 signature suggests its parent molecules, the original ices, are extremely rich in carbon chains, perhaps more so than in comets from our own Oort cloud. The color isn't just a visual spectacle, it's a chemical fingerprint pointing to a different kind of planetary nursery, one that existed around another star. The impossible anti-tail. Just when you think this comet couldn't get any stranger, observers have reported a feature that seems to defy physics, a faint tail that points towards the sun. This is the opposite of how a comet should behave. This bizarre sunward spike is known as an anti-tail, a phenomenon studied by experts like the late Czech astronomer Zdeněk Sekanina. It's an optical illusion created when Earth passes through the comet's orbital plane. It's formed by larger millimeter-sized dust grains that are too heavy to be pushed away by solar radiation, and instead get left behind along the comet's path like breadcrumbs. From our perspective, this trailing debris field looks like a spike aimed at the sun. For comparison, the famous comet Aaron-Rowland in 1957 displayed a stunning, easily visible anti-tail. Confirming this feature on an interstellar object would be a major discovery, providing invaluable clues about the size and density of its dust particles, information that is otherwise impossible to obtain from millions of kilometers away. It would tell us if the pebbles that built this alien object are different from our own. Not like the others. So we've had interstellar visitors before, but 3I Atlas is really breaking the mold here. Our first visitor in 2017, Oumuamua, was this bizarre cigar-shaped object with no coma or tail at all. Then, in 2019, 2I Borisov, discovered by amateur astronomer Gennady Borisov, arrived looking just like a textbook comet, though it had an unusually high concentration of carbon monoxide relative to water. But 3I Atlas, well, it fits into neither of these boxes. Its coma is intensely green, which is actually a result of powerful diatomic carbon emissions that far exceed what's typical. Its brightness surged unexpectedly, suggesting a different internal structure altogether. And then there's the hint of a sunward anti-tail, a feature so rare it's almost unheard of for an interstellar object. This combination of high activity, unique chemistry, and bizarre dynamics makes 3I Atlas a kind of Rosetta Stone for comparative planetology. Every new piece of data, honestly, forces astronomers to reconsider what it even means to be a comet. We're slowly building a catalog of object types from beyond our solar system, and 3I Atlas has just created an entirely new category. The Mars Encounter Strategy. So, what is the game plan for the Mars flyby? It's a massive technical challenge. The various science teams have been working for weeks to prepare, running simulations and negotiating for priority access in a complex effort between NASA and ESA. The ultimate prize would be to visually resolve the nucleus, to see the solid body at the heart of the glowing cloud, and look for jets of outgassing material. This is incredibly difficult due to the spacecraft's slewing rates, or how fast they can turn to track a moving target. Another key goal is to measure the deuterium to hydrogen ratio in its water vapor, a crucial clue to where and when it formed in its home star system. Even the data downlink is a challenge, as it will take up to 20 minutes for the signals to travel from Mars back to Earth, and bandwidth is limited. A single high-resolution image could take hours to transmit. Even with the best planning, the encounter is a high-risk, high-reward gamble on an object that remains utterly unpredictable. chemistry in motion. Let's dig deeper into the chemistry of that green glow. The dominant signature is diatomic carbon C2, but it's not the only chemical in play. Some initial spectra hinted at ionized carbon monoxide and the cyanogen radical, but separating those faint signals from the overwhelming C2 requires extremely high-resolution spectroscopy. This has led to scientific debate over factors like the G factor, which calculates how efficiently a molecule fluoresces in sunlight. The presence of cyanogen, often called a parent molecule, is particularly interesting because it's a direct breakdown product of materials like hydrogen cyanide, a key ingredient in the chemistry that leads to life. This detailed analysis is more than just chemistry, it's cosmic archaeology, helping astronomers understand the temperature and chemical environment where the comet originally formed. The sheer speed of 3I Atlas means solar radiation is sandblasting its surface, providing an unprecedented look at its pristine primordial layers, which have been frozen for billions of years. The fade begins. After 3I Atlas swings around the sun, its spectacular show will likely come to a quick end. As it speeds away from the sun's heat, most models predict its brightness will plummet, perhaps even faster than it rose. For anyone still hoping to track it, you'll need a telescope with at least a 20-centimeter mirror and a sensitive digital camera using long exposures. The focus will then shift to citizen science networks like the Interstellar network and Zooniverse, which will collect observations from dedicated amateurs. This amateur data is invaluable for long-term monitoring, as professional observatories with limited funding can't afford to spend weeks tracking a single fading object. These global networks will watch for post-perihelion outbursts or changes in the coma's shape, providing crucial data on how the comet shuts down after its violent encounter. It will be the collective work of thousands of skywatchers that writes the final chapter of this object's visit, ensuring its legacy is captured before it disappears into the dark. As 3I Atlas recedes, it leaves behind a trail of profound questions. What can this strange visitor teach us about the countless other planetary systems forming across our galaxy? Its unique chemistry and unpredictable behavior provide a rare glimpse into the building blocks that shape worlds different from our own. With the Mars flyby being our last chance for close-up observations, the data gathered will be analyzed for years, informing future studies of interstellar objects. The true nature of 3I Atlas remains an open scientific puzzle, one that invites all of us to keep looking up. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Simply Science.